Today I'll be answering a question from the Material Science subreddit. This person had an exam in metallurgy and they didn't understand how to solve the question, and their professor wasn't very helpful. So we'll help them out. So the question was basically that you have a material microstructure. We've got these two examples that the person has given to us, and there's a line drawn on the microstructure. So we'll draw this line. Instead of A, we'll call this point 1, and we'll call this 2, just because I'll use A and B later. So we've got this line drawn from 1 to 2 along the microstructure. And the question is, what does the graph for composition look like along this line? So let's make sure we understand what the question is asking. We're looking for some composition where you got distance. So this would be point 1 and this would be point 2. And we're going from here to here. And the composition would be some ratio of elements. So we'll say that at the top would be 100% element A, and at the bottom would be 100% element B. A and B are just the standard placeholder names for some random element. Could be nickel and aluminum, could be titanium and vanadium, whatever two elements. Potentially A and B could be combinations of multiple elements, but it's just a placeholder for elements. So the composition is some range between these two. Question is, what does this graph look like? Is it, for example, a flat line? Is the composition the same everywhere? Is the composition increase as you go from one end to the other? Does it have, maybe it's like kind of a flat line, but it has some fluctuations. Maybe it's like 100% A because there's no element B in there. So those are the options. The question is, what does this graph look like? So just to put, I arranged the microstructure here so you can see. So there's this light phase here, this light phase, and there's this dark phase. So if we look from the left side of the graph, we can see that we start in this light phase. This is alpha. And as we come along, then when we get to this point, we switch to the dark phase. That's phase beta. And we come along here, and then we switch back to the light phase alpha. So we've got these three segments on the graph where we've got this alpha phase, we've got this beta phase, and we've got the alpha phase again. So now what we need to know is to understand the composition of the phases alpha and beta. So there's many ways to do it, but the question said there was a phase diagram provided. So I'm assuming that the phase diagram also included temperature and composition. So this is a phase diagram. You've got your alpha, you've got your beta, you've got your alpha and beta, you've got your liquid, you've got your alpha plus liquid, you've got your beta plus liquid. If you don't understand this, the rest of the video is not going to make sense, and I can make a separate video, but that's not what this video is about. So you've got your phase diagram. It changes as a function of temperature. It changes as a function of composition. And probably the professor gave you an example of temperature and composition. If it's an advanced course, you maybe could have inferred it based on the microstructure, but let's just assume that you were given a composition and temperature. I also just want to reiterate alpha and beta are phases. So alpha and beta, these are phases. A and B are elements. This is A and B. And then C1 and C2 would be some random compositions somewhere along the X and Y direction. And then T1 and T2 would be some random temperatures. So this could be any temperatures we picked. And we'll just assume, for the sake of argument, that the teacher gave you some composition right here. And then the temperature would be along this line. So whatever composition this is, and temperature 2. Just for the sake of argument, that's what was given. So if we're at our point here, if we come all the way to the left, we'll see, well, here's our alpha phase, and so that has this composition, which looks, I don't know, let's say that's like 95% A and 5% B, something like that. And if we move over here, we'd have this composition over the beta phase. This is mostly B. I don't know, maybe it looks like slightly less B than was A, so it's like, let's say 92% B and 8% A, something like that. And now you know what the composition of your alpha phase is and the composition of your beta. Because again, this is, I think, the important concept the teacher wants you to understand, is that if you're in the alpha plus beta region, every phase is either going to be exactly the same composition of alpha, or it's going to be exactly the same composition of beta. So we come back to the graph we're trying to make, where I've laid out, hopefully, there's areas where alpha is and the areas where beta is. And remember, we said that alpha was mostly A, so we'll schematically draw that here. And it's going to be the same place everywhere. So in this region where we also have alpha, it's going to be the same thing right here. And then in this region here where we have beta, it's going to be this composition like this. And then between these areas, it's basically a straight line. I think this is, again, the crucial thing that your professor wants you to understand, is that you're going from one phase to the other. The composition change is pretty sharp. Now, I spent a good portion of my PhD specifically looking at these interfaces, so it's a little more nuanced than that. But for whoever's asking me a question on Reddit, for the purposes of whatever you're asking, this interface here is sharp. It's just a straight line. Just again to reiterate, this composition here would be C2, and this composition would be C1, as we're defining it. In this graph here, we've got the C1 here and the C2 here. So hopefully everybody's on board. Let's just do one more example real quick. So here we've got that other microstructure that was given in the problem. I'm not going to go through the whole phase diagram, but you can see it's basically the same. The only difference is that the spacing between the dark phase and light phase are now much shorter. So now it's going to look something like this. I'm trying really bad, but basically like this. And again, the key point is that you're switching between phase alpha and phase beta very quickly. And everywhere it's phase alpha, you're going to have this composition. And everywhere it's phase beta, you're going to have this composition. And then exactly where these two compositions lie depends on the phase diagram. And that's a whole separate video, which I'm happy to do. I'm kind of glad I had this Reddit post ask me a question, because I've always been thinking about videos and I've always thought like, oh, I'm going to take my time, I'm going to make it edited, and just hasn't happened, it hasn't happened, it hasn't happened. But here we go. We had this question that really needs to be answered visually. And put my foot down. I said I'm going to make it in PowerPoint and I'm going to get it done, even if it's not that good. So hopefully it's good enough. Hopefully this answers your question. And if any other viewer has other material science questions, feel free to send them my way. I'm happy to answer your questions. I hope this was helpful.